Hello and welcome to week 4 of geometry. It's hard to believe we're already a week, 4 weeks in. So just remember, as you watch this recording, you should have a math notebook out and taking good notes. You don't have to copy down everything word for word, but take notes on things that'll help you as you go through the lessons this week. Let's start with the warm-up problem. This is pulled from the concepts that we learned about last week. Specifically, this is pulled from Unit 1, Session 3. So it's not an exact problem that we did in Unit 1, Session 3, but the idea and the concepts this problem uses comes from Unit 1, Session 3, where we learned about different types of angle pairs. And what is the question? It is the measure of an angle. So we don't know the measure of an angle. That's our unknown. The measure of an angle is 6 more than twice its complement. So the unknown measure of an angle is 6 more than twice its complement. So what I want you to do is write an equation that represents this situation, and then I want you to find the measurement of each angle. So go ahead and click pause. Just a heads up, this is very simple, very similar is what I was trying to say, to a question that you did on the Unit 1 Session 3 assignment. So what would be a good idea is to try this on your own. Click pause, try it on your own, and then when you're ready to check your work with mine, click play. And then if you need to go back and redo that problem on the Unit 1 Session 3 homework assignment, maybe you got it wrong, now you'll have the tools to do that correctly. So go ahead and click pause, try this on your own, and when you're ready to check your work with mine, go ahead and click play. All right, so first and foremost, what I like to do is set my variable. So the measure of an angle, we don't know what that measurement is, so I'm just going to say x is going to represent that unknown measurement. So I'm going to start to write my equation. So here it says the measure of an angle, that's our unknown, x. I see the keyword is. In math, that always tells me equals. Is represents equals. 6 more, so 6 plus, because it says 6 more, than twice, so twice means 2 times something. Twice its complement. So remember, a complement is when 2 angles add up to 90 degrees. So it's when 2 angles add up to 90 degrees. So to find the complement, we would take 90 and subtract it from our angle measurement. So that is the equation that we're going to use to solve for x. And now what I'm going to go through and do is look and see, is there anything that I can simplify? Well, there is. Look on the right-hand side. We've got that 2 times 90, which I know is 180, and then 2 times negative x, that negative belongs to the x, is negative 2x. So the first thing I did was distribute out that 2. Now, is there anything more that I can combine, any more like terms on the right side? Yeah, there is. We can add that 180 plus 6 to give me 186 minus 2x. And I'm solving for x, so I want to get all my x terms on one side of the equation and all my constant terms on the other side. So I'm going to get all my x terms on the left side of the equation. So I'm going to add 2x. I'm going to move this 2x to the other side by doing the opposite, and I'm going to add it to both sides. And then I get 3x equals 186. I'm going to rewrite this up here. I'm running out of space. All right. Now we're one step away from solving for x. We're going to divide each side by 3 to solve for x. So x is going to equal 186. 186 divided by 3, which is 62. Now this is degrees, right? It's only half of my answer. So this is just one measurement of the one angle. The other angle, to find the measure of each angle, we would then do, remember they were complements of one another, so I can do 90 minus 62 to get the measurement of that second angle. 90 minus 62 is 28 degrees. So that right here is the measurement of my two angles, 62 degrees and 28 degrees. I'm going to move on to the next slide, so if you need more time, go ahead and click pause. So this week, we are going to complete Unit 1, Session 4, which is bisecting angles and segments. We're going to look at the distance formula and how to find the midpoint. Then we're going to move on to Unit 1, Session 5, where we're learning about parallel lines and transversals and a bunch of different angle pairs that are created when we have a parallel line that is intersected by a transversal, which you will learn all about. And then you're going to do your first project of the year, where you're going to create a map of a city, your own city that you make up. And there's certain specifications that you will have to place buildings in certain places based on angle pairs that you're going to learn about this week. All right, so a couple of quick reminders as you guys are starting to get comfortable with the online class. I wanted to clarify assignments versus quizzes. So at the end of every session, you always have a graded assignment you have to complete. That's just, think of it as a homework assignment. I know in Schoology it calls it a quiz because of the format I'm using, but think of it more as a homework assignment. It's practice. You can redo those. Versus a quiz is going to go over a true quiz will go over several sessions, like the quiz you just completed last week, over sessions 1 through 3. So even though Schoology, the format I use is called a quiz, don't think of every assignment as a quiz. Think of some of them as like homework assignments, practice problems. Those are the ones at the end of the sessions. Next thing I wanted to go over was notes. So make sure that you're reading over the requirements on the notes assignment page. Spend some time, look over what I require, look over the rubric. So make sure that you're taking notes on the weekly recording. That's what you're watching right now, as well as the Schoology lessons. And then as you go through the Schoology lessons, there's lots of different opportunities to learn based on your learning style. There's text, and then there's videos. So pretty much every page at the end of them will have a video that goes over the same thing that's in the text. So use what works best for you and your learning style. And then, last but not least, pay attention to due dates. I know a lot of you have a lot of stuff going on in your day-to-day life and your weeks. But make sure that this class isn't taking the back seat in your life. Use that pacing guide that I give you every week. If you're having trouble pacing, take advantage of that pacing guide that I give out every week of what to work on each week so that you don't get behind or miss a due date. I think that I can vouch for all students who have taken an online class in the past. Getting caught up once you get behind can be very daunting. So stay on top of your schoolwork. That way you're not playing the catch-up game and also trying to learn new material at once. If you stay current, it's going to make your life a lot easier. All right, so the first thing we're going to learn about this week is the distance formula. So this probably looks familiar to you or sounds familiar. You did cover it back in algebra, but you might have forgotten it, and that's okay because we're going to review it right now. So does anybody remember what the distance formula is? We actually have a formula we can use to find the distance between 2 points on a coordinate plane. We have a formula. So that's one way that we can find the distance between 2 points. So go ahead and jot down in your math notebook if you remember the distance formula. If you don't, something that you could do right now is click pause and do a quick Google search. I do want to remind you guys about how much information is available at your fingertips, and don't always rely on me to tell you or the textbook to tell you. Try to do some finding of your own sometimes. So go ahead and Google distance formula and see what pops up for you. All right, so let me jot down the distance formula. So D equals the square root of x2 minus x1 plus the difference between y2 minus y1. Well, what is all this? What's the x's and the y's? What do those represent? Well, remember, you're finding the distance between 2 points, like this. This point here has a coordinates -2, 1, and this point here has a coordinates 1, 5. And remember, coordinates, we always give you x coordinate first, followed by your y coordinate. So since this is our first point, this would be our x1 and our y1. This is our second point, so we would call this our x2 and our y2. So those are the points then that we would plug into our formula. So let's go ahead and do that. Let's plug in these points and find the distance between these 2 points, -2, 1 and 0.15. So I'm going to take the x2 minus the x1 point coordinate. So my x2 is 1, and I'm going to subtract from that -2. Yes, we do have a double negative. That is okay. And we should have a double negative if we're subtracting a negative number. And then, oops, I forgot to put the squares in my formula. I was going to say something looks missing there. Then we're going to square that difference. Then we're going to add to it. We're going to do the same thing for the y coordinates. We're going to take the second y coordinate and subtract from it the first y coordinate. So the second y coordinate is 5. We're going to take away 1, and then we're going to square that difference. And then when we're all done with all that, we'll take the square root. So now let's go through and clean up our expression. So anytime I have a double negative, it becomes a positive. So I'm going to have 1 plus 2 is 3. We'll square that in just a sec here. 5 plus 1 is 6, and we're going to square that. So let's go ahead and square. 3 times 3 is 9, and 6 times 6 is 36. Then let's go through, and what is 9 plus 36? If you said 45, you are correct. So we're going to take the square root of 45. Whoops, I put 49. Meant to say 45. So is the square root of 45, can we find, is that a perfect square? Is there any number times itself that would give us 45? No, there isn't. But we can simplify this radical. So when I say simplify radical, we're looking for factors of 45 that are a perfect square. And I know 9 times 5 gives me 45. And I know 9 is a perfect square. So if I say 9 times 5 underneath the square root, that's the same thing as saying square root of 45. But I can simplify the square root of 9. The square root of 9 is 3. So 3 comes on the outside of my radical sign, and 5 stays on the inside. So this is our final answer. This is the distance between these 2 points. And we found that using the distance formula. There is actually one other method that we can use to find the distance between 2 points on a coordinate plane, and I'm going to leave that other method for you guys to learn about this week in your Schoology lessons. Remember, I don't have enough time to go through everything you're learning this week, so I just want to hit on the most important things, and sometimes people struggle with plugging their coordinates into the distance formula, so I just wanted to go over the one method today. In Schoology this week, you're going to learn that you can plot these points on your number line. You can plot these points and actually find the distance using the Pythagorean theorem. You're going to draw in and create a right triangle and use the Pythagorean theorem. That's another method that you can use. So you'll learn more about that in depth this week. Moving on from the distance formula, you're also going to learn about the midpoint, how to find the midpoint of a line. I'm going to save that for you guys to learn about in Schoology as well. But moving on to Unit 1, Session 5, where you're going to learn about a whole bunch of different angle pairs that are created when we have 2 lines that are intersected by a transversal. So you might be saying, well, what is a transversal? So a transversal is a line that intersects two other coplanar lines. So let me draw in some lines here really quick. We've got two lines here. Now, if the definition says a transversal intersects two coplanar lines, so I'm going to draw in a transversal in red. Here we go. That's a transversal. It is a line that intersects two coplanar lines at two different points. It intersected here and here. So in red here, this is my transversal. The transversal intersected these two lines at 2 points. And when I drew in that transversal, I created 8 different angles. Let's find those angles. Here's one angle. So from here to here, that's one angle. Here's another one, angle 2. Here's another angle, angle 3. Here's another one, 4. You get the idea, 5, 6, 7, 8. So when we have a transversal that intersects two lines, we create 8 different angles. And we're going to talk about some patterns that occur between some of the angle pairs. But before we do that, I want to go over the idea of interior and exterior. So between our two coplanar lines, all these angles would be considered interior angles. They're interior of our two lines here. So we would call all these angles interior angles. So angles 3, 4, 5, and 6, they would be interior because they're located between our two lines. Whereas on the outside of our two lines, let's do this in pink, our outside, we would call these exterior angles. And this is just going to help you guys when you're learning about some of the different angle pairs that exist when we've got transversals that intersect two lines. So go ahead, make sure you take these down in your notes. I'm going to move on to the next slide. So if you need more time, go ahead and click pause. Alrighty. So let's talk about some of the different angle pairs that are created when we have a transversal. Can you identify the transversal in this diagram? This right here is our transversal, line N. This is our transversal. So let's talk about some of the angle pairs that exist when we've got two lines that are intersected by a transversal. So remember, angles 3, 4, 5, and 6, these are all interior angles, and angles 1, 2, 7, and 8, those would be all of our exterior angles in relation to our two lines that were intersected by that transversal. So, first type of angle pairs, corresponding angles. They are located in the same position. That is what corresponding angles are. They're located in the same position. So like angles 2 and angle 6, if we were to slide line M up to match up with line L, 2 and 6 are essentially sitting on top of each other, right? They're the same angle. So angles 2 and angle 6 are an example of corresponding angles. Since they sit on each other, since they're essentially the same angle, they're also congruent. So corresponding angles will always be congruent. Can you name another set of corresponding angles? 3 and 7. So angles 3 and 7, those are corresponding. 1 and 5. 1 and 5, those are also corresponding, and then 4 and 8. Those are all examples of sets of corresponding angles. So I color-coded those for you, and they are congruent. Remember, they will have the same angle measurement. So if I said angle 2 was 120 degrees, angle 6 must also be 120 degrees. So that is corresponding angles. I'm going to erase all the color coding, so if you want to click pause now, do that because I'm going to get rid of those so we can go on to the next type of angle pair. Exterior angles. We're going to look at a type of exterior angles called alternate exterior angles. Remember, exterior angles are the angles on the outside of our two, like this over here and over here. Those are all of our exterior angles. And then we've got an alternate. So when it says alternate, we're going to go on alternate one side to the other side of the transversal. Those are alternating exterior angles. So angle 1 and angle 8, are an example of alternate exterior angles. They're on the exterior of our two lines, L and M. They're on the exterior, and then they alternate on different sides of the transversal. So angles 1 and 8 are alternate exterior angle. There's only one other set of alternating exterior angles, and that's angles 2 and 7. 3, 4, 5, 6, these are all interior angles, so they can't be considered alternate exterior angles. Alternate exterior angles are also congruent. So angles 2 and 7 have the same measurement, and 1 and 8 have the same measurement. I'm going to erase all the color coding. And let's go over our next example, or our next type of angle pairs, which are alternate interior angles. So now we're dealing with just the inside between our two lines. So the inside, all this space. And then we're going to alternate. So we have to alternate the opposite sides of the transversal. So angles 3 and 6 are examples of alternating interior angles, and 4 and 5 is the other set, and that's it. And these are also congruent, meaning 4 and 5 will have the same measurement, and angles 3 and 6 will have the same angle measurement. You're going to learn about some additional, so all these were congruent types, right? As you go through your Schoology lessons, you're going to learn about some same side interior angles. So 3 and 5 would be same side, and they're both interior. I'm just going to go over this really quickly, but they're going to be supplementary, meaning they have to add up to 180 degrees. So you're also going to learn about same side exterior angles. So I'm not going to go over this in this recording. It's getting a little too long, and I want to wrap things up. So I'm going to leave some of you this to learn on your own in Schoology. All right, so ready for our key phrase assignment. There's actually 2 parts to it this week. Part 1, you need to answer what is a transversal. And then part 2 is a grade check. So for part 2, I want you to tell me what is your current grade in geometry. It forces you to go into the grades tab, look to see what your overall grade is. And if you have less than a 70%, you need to also tell me 2 goals that you can use to help improve your grade. This can be, I'm going to go back and submit missing assignments. I just realized I've got some missing assignments and they're pulling my grade down. The other one, you could say I'm going to come in and get some math help. Maybe you are going to redo low scoring assignments. Maybe you have another idea. These are just examples of things that you could use for goals to help improve your grade. So remember, you only have to do this if you have less than a 70% in the class. If you have 70 or greater, you just need to tell me what your current grade is. And that's it. Have a great rest of your week, and let me know if I can help you out in any way.